Hello everyone, welcome to the video on Perkins reaction, which is a very important reaction in carbonyl compound. In this video, we will be learning what is a Perkins reaction, the reagents involved in the Perkins reaction, and finally its mechanism. So, in the earlier video, you are already familiar with the aldol condensation, where a analyzable aldehyde, that is having an alpha hydrogen atom, is reacted with a base or an acid and condensed to give a beta hydroxyaldehydes or ketones, which are commonly known as aldol. In the presence of a base, the alpha carboanion is formed, which attack as nucleophile on another molecule of aldehyde or ketone, resulting in the condensation of two molecules, giving rise to an alkoxide which takes up a proton to form an aldol. In a very analogous manner, Perkin reaction or Perkin condensation also takes place. Here in the Perkins reaction, it is an organic reaction which is used to convert an aromatic aldehyde and an aliphatic acid anhydride in the presence of the salt of corresponding acid anhydride to an alpha beta unsaturated carboxylic acid. That is, here we wish to condense an aromatic aldehyde with an aliphatic acid anhydride, resulting in the formation of unsaturated carboxylic acid, and this reaction we call it by the name Perkins reaction. As I said, the Perkins reaction is very much analogous to the aldol condensation, and it was given by William Henry Perkins, which is used to make unsaturated, that is alpha beta unsaturated aromatic acid or the carboxylic acid, which were commonly known as the cinnamic acid. In the case of an aldol condensation, two aldehydes or two ketones are going to undergo a self-addition in the presence of NaOH to give the product. Here in the case of the Perkins reaction, an aromatic aldehyde is going to react with an aliphatic acid anhydride in the presence of the salt of the corresponding acid anhydride to give the alpha beta unsaturated carboxylic acid. So the reagents which are involved in the Perkins reactions are an aromatic aldehyde, an anhydride and sodium acetate. And the products which we are going to get is an alpha beta unsaturated carboxylate. Since here we are taking an aromatic, we get an alpha beta unsaturated aromatic acid, which are commonly known as cinnamic acid. So this is the Perkins reaction. So when an aromatic aldehyde is treated with acetic anhydride in the presence of sodium salt of the same, that is the acetic acid, sodium acetate, we get an alpha beta unsaturated aromatic acid, that is the cinnamic acid. Here the alkali salt of the carboxylic acid act as a base and it removes a proton to generate the alpha carboanion, which in turn attacks the aromatic aldehyde to give the corresponding aromatic unsaturated cinnamic acid. So let us learn the reaction of the Perkins in detail. I said here we are going to take an aromatic aldehyde, and the aromatic aldehyde employed in the Perkins reaction is benzaldehyde. It is going to react with an aliphatic acid anhydride. So here the aliphatic acid anhydride we are employing is acetic anhydride. So we know very well when two molecules of acetic acid condense with the elimination of one molecule of water, we get acetic anhydride. So benzaldehyde is C6H5C double bond OH. And the acetic anhydride here is CH3C double bond O C double bond O CH3. So an aromatic aldehyde reacts with an aliphatic acid anhydride in the presence of the corresponding salt. So here what do I mean is, here if I take an acetic acid, I am going to employ the corresponding salt, that is sodium acetate. By chance here I am going to take propionic anhydride. Here the salt will be sodium propionate. So the corresponding salt is being used as an reagent. So with this we are going to get an alpha beta unsaturated carboxylic acid. So since the double bond is between the alpha and the beta, we call it by the name alpha beta unsaturated carboxylic acid. Here it is the cinnamic acid, and the product here we are getting, the another product is the acetic acid. So let us go for the mechanisms of Perkins reaction. So in the Perkins reaction, the first step is the formation of a carboanion. So in the earlier slide, I said we are going to use the corresponding salt, that is the sodium acetate. So this will be used, and upon hydrolysis, since salts undergo hydrolysis, we get an acetate ion and sodium. The acetate ion from the sodium acetate is going to remove a proton, which is an alpha hydrogen. And one more thing here is the aromatic aldehyde which we are going to take here does not have an alpha hydrogen, whereas an anhydride will have an alpha hydrogen. So coming to the mechanism, the acetate ion which is obtained from the sodium acetate is going to remove or the proton, which is a alpha hydrogen. So we can write the acetic anhydride CH2-H C double bond O O C double bond O CH3. So this is the structure of acetic anhydride, and here the acetate ion takes up a proton, that is particularly the alpha hydrogen from the acetic anhydride, giving rise to a carboanion which is resonance stabilized. And the acetate ion, upon taking a proton, gets converted to acetic acid. So the acetic anhydride in the presence of the acetate ion loses an alpha hydrogen to form the carboanion, which is the first step in the Perkins reaction. The second step in the Perkins reaction is attack of the carbanion on the carbonyl group of the benzaldehyde. So for the convenient purpose, we'll write the structure of benzaldehyde as C6H5C double bond OH. Because of the pi bond, the electrons are pulled more towards the oxygen, getting a partial negative, and carbon gets a positive charge. So in the second step, the carbanion that has been formed because of the removal of a proton, the carbon gets a negative charge, and this carbanion acts as a nucleophile, and it is going to attack the positive center of the carbonyl group of the benzaldehyde. So it is a very simple for us to write the reaction. Just to this C6H5C double bond H, you are going to add the carbanion. Since there is an addition of this nucleophile to the benzaldehyde, the double bond is shifted and oxygen gets a negative charge, and hence this we call it by the name alkoxide ion. So the structure of alkoxide ion is C6H5CH-O minus, and the rest is of your carboanion. So in the second step, because of the attack of the carboanion on the carbonyl group of the benzaldehyde, we are getting the alkoxide ion. The next step is the protonation of the alkoxide ion. So this is the alkoxide ion where an oxygen is carrying a negative charge. This undergoes the process called protonation or the addition of a proton. So we know in the first step acetic acid has been formed. This undergo ionization to give the acetate ion and H plus, and this H plus is taken by the alkoxide ion and we get the corresponding beta hydroxy anhydride. So here the only the change is to the negative oxygen we are adding a H plus. So a beta hydroxy anhydride is obtained. That is the step here we call by the name protonation. The next step here is the process called dehydration. So D means removal, hydra means water. So here we are going to remove a water molecule. So let us look from which part of the molecule the H and OH has been removed. So this is your benzaldehyde moiety where to the oxygen we have added a proton. So this OH along with a proton from the acetic anhydride is removed in the form of water molecule. Because of the dehydration and unsaturation results, and here the unsaturated, this is the acetic anhydride moiety, and the next carbon we designate to be alpha, the next to be the beta. So an unsaturation has been resulted between the alpha and the beta. So this is the C6H5CH double bond CH, C double bond O, C double bond O, CH3. So the last step is the hydrolysis. So this big unit we are going to break in presence of water, and hence we call it by the name hydrolysis. So here students kindly remember, so this is the breaking point. Upon the breaking there will be addition of OH to the benzaldehyde moiety and proton is added to the side. As a result, we are going to get an alpha beta aromatic unsaturated acid which is called as cinnamic acid, and the other product here we are getting is the acetic acid. So and the final step we are getting the two products, cinnamic acid and the acetic acid. Let us have a recap of this reaction. So the first step, the acetate ion removes a proton from the acetic anhydride, resulting in the formation of a carbanion, and the acetate ion takes up a proton to give the acetic acid. Next, this carbanion attacks the benzaldehyde to give the alkoxide ion. This alkoxide ion in turn takes a proton from the acetic acid to give the beta hydroxy anhydride, which undergo dehydration and results in the formation of an unsaturated protein which undergoes a hydrolysis to give the two products, namely the cinnamic acid and the acetic acid. And this is all about the Perkins reaction. Thank you.